Good morning, ninth graders. Welcome to the lesson of graphing quadratic function. Today we're going to use everything that we learned in the past few days to graph a more accurate quadratic function graph. So to start off, step number 1, we're going to start by finding the axis of symmetry. So axis of symmetry. And remember the formula for that is x is equal to negative b over 2a. So if you refer back to our quadratic function on the top here, b is next to the x value. So our b in our first example is the 4. Alright, so I'm going to circle b here in red and circle 4, negative 4 in red, just so you can have a correlation between the two values. That equals a negative 4 over 2a, and our a value is a value right in front of the x squared value. In this case is the 1 in front of the x squared. So I'll put a little 1 here, and I'm going to circle that 1. So it'd be 2 times 1. So 2 times 1. So if you simplify that, a negative times a negative will give us a positive, so this will give us a positive 4 over 2 times 1 will give us a positive 2. And if you simplify one more time, 4 over 2 will just be a positive 2. So our axis of symmetry is at the line x equals 2. And remember, the axis of symmetry is just the line that cuts the parabola right in half. Alright, step number 2. You want to find the vertex. So let's find the vertex. The vertex, and you find that by substituting the x value we found in the axis of symmetry into our equation. And remember, the vertex has a x coordinate and a y, x and y coordinate. So let's substitute a 2. So everywhere you see an x up here, we're going to substitute a 2 in for the x. Alright, so y is equal to 2 square minus, let me write this in purple so we stay consistent with our colors, minus 4 times 2 and then minus 5. So 2 square is 4. So y is equal to 4 minus 4 times 2, which is a minus 8. So minus 8, and then subtract 5. And that equals a negative 9. So the vertex is not negative 9. Remember, the vertex has an x and a y coordinate. So our vertex, I'll draw a line just to break that apart, would be our x, which is 2, and our y, which is 9. So the vertex would be at 2, negative 9. Alright, step number 3, you want to find the y-intercept. And remember, to find the y-intercept, all you do is set this is x equals to 0. So everywhere you, let's go back to our original equation all the way next to example 1 on the top. Everywhere you see an x, you're going to substitute the 0 in for the x. So I'm going to rewrite our equation. Y is equal to x squared minus 4x minus 5. So everywhere I see an x, so here and here, I'm going to replace it with a 0. So y is equal to 0 squared minus 4 times 0 minus 5. And when you simplify that, you'll get a negative 5. So your coordinate for your y-intercept would be at x is at 0 and y is at negative 5. Alright, step number 4. After you find your y-intercept, you want to find your x-intercept. And to find the x-intercept, we're going to use the box method we did yesterday. So draw a box. And then we're going to put the first term, which is x squared, in the top left-hand corner. So x squared. And then we're going to put the last term, which is negative 5, at the bottom right corner. And I'm going to put a little box down here just so we can check at the end. And then the next step, we're going to multiply the coefficient of these two values. So the coefficient for x squared is a 1, and then the coefficient of negative 5 is just negative 5. So 1 times a negative 5 equals a negative 5. After we do that, we want to find the factors of negative 5. So we know that 1 times 5 is a negative 5, and also negative 1 times a 5 is a negative 5, or 1 times a negative 5 would be a negative 5. So you want to choose the values. In this case, there's only two factors here, but there's more. You want to choose any of the value down here that when you add, you will get to negative 4. So here we have 1 times negative 5, or negative 1 times 5. So the value that will add and give us a negative 4 would be 1 and negative 5, because 1 plus a negative 5 will give us a negative 4. So again, you can put these two values, the 1 and the negative 5, in any of the empty boxes. As long as you be consistent, you will be fine. And when you put them in there, remember to put an x next to it. So I'm putting negative 1x on the bottom left hand box, and then negative 5x on the top right hand box. Alright, so next up, I'm going to put a box over this the two bottom box, just so we can concentrate on the top two box and factor the greatest common factor out. So if you look at 1x squared and negative 5x squared, the only thing they have in common is the x in them, the x term in both of them. The 1 and the 5, negative 5, don't have anything in common except 1, so we're not going to bother with that. So I'm going to factor a x out. Alright, the next step, you're going to ask yourself, x times what value will give us an x squared? The only value that can get us, multiply x to get x squared is an x. So I'm going to put an x on top. Ask yourself the same question, x times what value will give you a negative 5x? And the only value will be a negative 5. Alright, go ahead and remove the box here. Alright, so next one, you're going to ask yourself, this x up here, or this value, whatever this value is, in this case it's the x, multiply what number will give you a 1x? So the only number that will work would be a positive 1. Alright, the last piece, you want to check if this positive 1 times this negative 5 get negative 5. And it does. 1 times a negative 5 is a negative 5. So that's true. So I'm going to check the box saying that check that. Alright, the next piece. Yesterday we came all the way down to where we factor completely to y is equal to x plus 1 times x minus 5. Alright, so before we go further on to finding the x-intercept, I want you to draw your attention to the graph on the right hand really quick. So just to remind you, x-intercept is where any graph crosses the x-axis. So in this case, it will cross the x-axis right here, and also to the right over here. So as you can see, the value of this one particular one here, our x value is a -1, and the y value is a 0. The one to the right here, our x value is a 5, and the y value is a 0. So as you can see, anytime we have a x-intercept, our y value is always 0. So right now we want to, so when we solve for the x-intercept, we know that the y value is always 0. So draw your attention back to the equation to your left here. We're going to set this y value to equal to 0 and solve for x. So I'm going to set y equals to 0, and that's going to equal to x plus 1 times x minus 5. Then you're going to write x plus 1 equals to 0, and x minus 5 equals to 0. So to solve that, I'm going to subtract 1 on both sides, subtract 1 on both sides. That's going to cancel, and x is going to equal to -1. That's one of the x-intercept. Add 5 to both sides. The 5 cancel on the left. X is equal to +5. So that's the other x-intercept. Alright, so I'm going to slide this up just a second. Step number 5, your last step, all you're going to do is just plot the points on the graph. Alright, so let's start out by plotting the vertex. So I'm going to slide this up just a bit. So the vertex we found in step number 2 was 2, 9. Alright, so let me label my graph really quick and let me zoom in just so this is a little bit bigger. Alright, so on the x-axis, I'm going to go up by 1s. 1, 2, 3, 4, 5, 6, 7, 8. -1, -2, -3, -4, -5, -6, -7, -8. And then the y's, I'm going to go up by 2s. -2, -4, -6, -8, -10, -12, 2, 4, 6, 8, 10, 12. So again, we said the vertex was 2, -9. So I'm going to go over 2 and then down 9. 9 is like roughly right here. Make a point. The next value, we said the y-intercept is 0, -5. So y-intercept is at 0, -5. 0, -5, which is roughly right here. The next value is the x-intercept, and we said the x-intercept was at x is equal to -1, and x is equal to positive 5. X is equal to -1, and x is equal to positive 5. Alright, so when you're done plotting those 4 points, go ahead and connect them with a smooth curve, and you should be good. So that would be your parabola for this function. Alright, so I encourage you to pause the video and give example 2 a try. But before you do so, I made a slight mistake. So at 2, your value here for the 6, change that to be a 7 instead of a 6. So instead of a 6x, I'm going to put a 7x instead. Positive 7x. Alright, so go ahead and pause the video and give this a shot. Alright, looks like I went over the 10-minute mark all the way to 16 minutes already. Alright, so I'm going to do part 2 of this for example 2. So I'll see you in part 2.